Hey, you! Over here! Welcome to physics lesson number 1. Yeah, just do the chopper. Okay, wave basics. So this video should go pretty quick. Most students, I believe, have some pretty good background in this. So a wave, this is going to be a wiggle in space and time that transfers energy. So if you picture this little dot there as energy, right, ready, wait for it, there it is. That is being transferred along our wave. And the purpose of this is to transfer energy from one location to another. All right, parts of a wave. So we'll start off with the crests or peaks right here. This is the high points of our wave. Then we have our low point, which is known as our trough. The direction of the wave, so in this case it's going this way. It could obviously go the other way, or that way, or that way, or that way, or that way, or whatever way it wants to go. This part right here from the point of zero displacement, that's known as our amplitude. And then you might have heard this term before, one wavelength, that is crest to crest, trough to trough, or two successive points on two different waves. And this is one complete wave, one up and down, also known as one cycle. Okay, so definition. So a crest, hey, is a point of maximum displacement, trough, point of maximum negative displacement, and then here is our wavelength, which is measured in meters. And that is signified by the symbol lambda, which kind of looks like an upside down Y. Y. Upside down. Cool. Isn't that fun? And again, distance between two successive crests, troughs, or any two identical points on a wave. All right. Period. Period is symbolized by the capital letter T. And that is not the same as a lowercase t. I know, what, elementary school, how cool is that? Time is a measure of time, where period is the amount of time per cycle. Then we have frequency. Frequency is the reciprocal or inverse of period, and that is measured in hertz, because it hurts to do these problems. I'm going to assume you laughed on that one. And that's going to be cycles per time. You could also just go with the inverses of them. So frequency is 1 over period, and period is 1 over frequency. And if you were to multiply these together, you would get this nice number 1, right? Because anytime you multiply a reciprocal by a reciprocal, it is the number 1. Alright, so some things we need to know about waves. There's two types of waves. There is a mechanical wave and an electromagnetic wave. Mechanical waves are the ones that you're probably used to seeing. These are the ones that require a medium or substance for them to travel through. So sound is a mechanical wave. Water is a mechanical wave. Doing jump rope, mechanical wave. Electromagnetic waves, or EM waves, are different in the fact that they don't need a medium. This is how light travels. So they don't need anything to travel through. They can go through the vastness of space without having to have anything for it to travel through, which is a hard thing to wrap your head around, and has been bugging scientists for years. They used to have this idea that space wasn't a vacuum, but this weird stuff called ether that the light was traveling through. I don't even know, but hey, there's that. What's up, history? All right. So of the mechanical waves, there's two types that we're going to talk about in here. The first is called a transverse wave. This one propagates. In other words, you're going to have a wave that is generated. It goes up and down and then up and down. Or it can go left to right or left to right. All are going to make a transverse wave. So this is our standard wave. These are the ones we see most often. This is usually what we think of when we think of a wave. Like, hey, here's the amplitude, and then here is our wavelength, crest to crest, or, trough to trough. Either way works. One complete wave from here all the way over here. So what we can do then besides that is something called a longitudinal wave. A longitudinal wave is a wave that goes back and forth parallel or along the same axis. So this is what we see when we see like springs, and when you squish them and compress them, you get a crest. And then when they get stretched out, not stressed out, I mean maybe they're stressed out, I don't know, I haven't asked them, I guess that's not very polite, but if they get stretched out, you get your trough, right? So here is our wavelength, trough to trough or compression to compression. Who would have thought? Alright, so that ends 10.1 notes. I will talk to you again in a little bit with 10.2. I hope you enjoyed our time together. It has been fun. It has been real, but I don't know if it's been real fun. Oh, I got jokes. Alright, I'll talk to you later. Goodbye.